Good morning, everyone. So next up, we have Adam Harvey. Adam is a software developer who has worked on a number of interesting and occasionally even useful things in his 2-decade career. These include prototyping the worst mesh network, that's hard to say, of all time, based on Android phones, discovering how to reliably lock up a Windows computer by writing an in-browser video editor, and most usefully, removing the original MySQL API from PHP. Welcome, Adam.
Thank you. Yes, many truly epic technical achievements in there. My name is Adam, as Betsy just said, and I work for a company called New Relic. We do performance monitoring stuff, and that literally is the only thing in my entire talk that has any relevance to that. You can find me on Twitter at @lgnome. You will eventually be able to find me on the Fediverse when I get around to setting up the nice domain hack that I got a while back. And I'm going to talk to you about what PHP learned from Python. And specifically, what I'm really going to talk about is what PHP learned from the Python 2 to 3 transition. Besides all of those amazing technical achievements, I am a somewhat lapsed member of the PHP internals team, which is basically the equivalent of the Python core developers group. I've also written a pretty good amount of Python over the years. 2 of my last 4 jobs were primarily Python-based, so I'm not going to say I know what I'm talking about, but I at least don't feel like a total fraud up here. This talk really isn't about PHP per se. It's barely about Python, honestly. But I'll provide some quick background about PHP just for those who aren't familiar with it. For those who don't know PHP, it is the world's leading programming languages for implementing blogging platforms with massive security issues. It also drives a truly astonishing percentage of the web. Back in the day, it was, I think it peaked at like 80% of website backends were written in PHP, and depending on how you measure, it's still well over 50%. Now, a lot of that is a long tail of WordPress sites, driving little catalog sites, blogs, that kind of thing. But basically, PHP is all over the place, particularly in a web context. PHP features an unusual versioning system based on Octal, apparently, with some modifications. You will note that there was no 6. 6 didn't happen. PHP made the jump from version 5 to version 7 about 3 years ago. Like Python 3, PHP 7 was and is an attempt to clean up some of the wartier bits of the language and the runtime, while hopefully bringing users along for the ride. I was much less lapsed on the internal team at the time this was happening. I was reasonably active in it. All the good bits were done by other people. I just mostly ripped things out and then waited for people to scream into my inbox. And one of the things that was brought up often was how the Python 3 transition, which at the time was about 7 years, had been underway for about 7 years at that point, had gone and what we could learn from it. So I'm going to talk on a holistic level about upgrades, and then we'll get into some examples. As developers, we tend towards liking big changes, green fields, rewrites. Everything I wrote a year ago was terrible, so now I'm obviously going to do it better. But if a language upgrades in a forest and nobody can or will upgrade, does the new version really exist? It doesn't actually matter how awesome it is or how clean. If it's as hard to go from version 5 to version 6 as it would be to migrate to a different, more established, maybe better supported tool, maybe with a better ecosystem, why wouldn't your users do that? Why do they need to go from version 5 to version 6 if they can go to super awesome new thing that everyone is using? So you end up, when you're trying to design an upgrade, and this applies to much more than just languages. This is, if you write any software that has downstream users, libraries, APIs, anything like that, then you end up trying to figure out how to, balance carrots and sticks, to use a metaphor. Your sticks are the things that are going to hurt your users. They're the things that break. It doesn't matter how well-founded the change is. You might be doing it for extremely good reasons, but change is still scary. And you've just made work for a lot of people, which, may be good from a financial perspective for them, but sustainability and all that, what Vicky talked about this morning. So since most people don't want to incur pain for no gain, you also need carrots, preferably a lot of them, fields of carrots, because you want to entice your users to come along with you. Just saying, this is better because is not good enough. You actually need to be able to say, this is better because A, B, C, D, E. The other problem you have, and I've developed, this diagram is from a programming language context, but you could kind of change the nouns and it applies to a lot of things, which is you probably have downstream users who need to support both versions. If you're doing a language upgrade or an API upgrade or something like that, anybody who's building tooling, and in the programming language context, it's usually libraries and frameworks on top of that, need to be able to support both of the versions, if it's at all possible to do so. Because their users are going to need to migrate from your old version to the new version. So you've got to think about it as layers. Like you have to facilitate more than one layer in making that transition. So they have to live in that little bit in the middle, which means that, or they have to come up with clever ways to have version-specific code. They both suck for different reasons. So the best way to make it not suck for them is to make it as wide as possible, make it very easy, make it so that the code that is valid in the old and the new versions works to the greatest possible extent in those versions. Okay, so let's bring this back to Python. This is a Python conference. So let's apply this methodology, the carrots and the sticks, to Python 3. I am a bright, sunny person, but it's the middle of winter, so let's start with the sticks. What made it hard to upgrade from Python 2 to Python 3, and what did we learn from that? And particularly I'm looking at the earlier days of Python 3. If you're going from Python 2.7 now to Python 3.7 now, it's actually not quite so bad. So some of what I'm going to talk about is outdated, and I know it's outdated, but I'm also talking about the process here. So let's start with strings. Strings are a pernicious nest of stringy, snaky things. They're also fundamental to like everything, right? There's not a lot of stuff that you're doing, even if you're just labeling like numeric series or your machine learning model that works on blockchain and does stuff. You're still going to label stuff with strings, particularly for the sorts of things that Python and PHP users are using. Web backends are all strings, basically, essentially. And Python 3 significantly changed the semantics of what strings were, how you declared them, how you manipulated them, and how you used them. So the intention when this was being designed about the Python 2.5, 2.6 days with a view forward to Python 3 was that well-formed modern Python 2.6 code could be transformed using the 2 to 3 tool. This was one of the times I was actually a professional Python developer rather than just a dilettante. The problem was at the time I didn't know anyone who was actually writing well-formed modern Python 2.6 code. The reason being actually fairly obvious, which was that at the time, particularly back then, this is a little bit less the case now with the rise of things like Docker and Vagrant, but at the time everybody was deploying Python on whatever Linux distribution or maybe just the system Python on Mac OS, which was usually, depending on what distribution you were running, quite possibly 2 or 3 versions out of date. So you couldn't write modern Python 2.6 code because you were running Red Hat, whatever it was at the time, and it had Python 2.3. Which also meant, therefore, that none of the major frameworks and libraries were writing modern Python 2.6 code because they had to support those old versions as well. So great, you have a tool that could convert this. There was another problem there too, which was that it turns out that users don't really want to run separate tools to convert their code. It's an extra step in a build process, and build systems suck. So that was another issue. I won't get too deeply into that, but that was also a problem. Now, obviously this wasn't insurmountable. The tooling did improve. A few years after Python 3 came out, a package called 6 became really popular, and still is. And 6 basically provides a whole bunch of compatibility shims for standard library changes between Python 2 and Python 3. It's really cool. Probably whatever framework you use actually uses it. And once you could drop Python 2.5 support, really the compatibility story wasn't that bad. A lot of the language changes were more smoothed over. But there was a problem with this. This is how you declare a Unicode string literal in Python 2. There's a little U prefix. This is how you opted into the new behavior. In Python 3, you didn't need this U prefix because strings by default were Unicode and you had to use a B prefix for binary strings. Here's the problem. Python 3.0 dropped this syntax because it was technically useless in Python 3.0. What this meant was that you couldn't actually write a Unicode string literal in a completely cross-platform way without actually invoking a function on it between Python 2 and 3. I think it was about 4 years after Python 3.0 came out, this was finally corrected in Python 3.3, which re-added this syntax just as an alias for standard strings. This is a really good example. If you remember the Venn diagram I showed earlier, which was obviously totally scientific, this is a really good example of just narrowing that intersection for no real reason. Like, supporting this in Python 3.0 would not have been technically difficult. I looked at the patch that re-added it to 3.3. It wasn't big. The PEP to reinstate this syntax noted that this had been a problem in practice for porting projects like Pyramid, Verkzug, Django, Flask. You know, these are pretty fundamental projects, particularly a few years ago. Like, these were, if you were writing stuff in Python, you probably used at least one of those. So if all of the things that you're working on are underpinned by these projects, and these projects can't easily support both versions because of this one little syntactic change, who was also going to come along for the ride? I mean, Django just didn't support Python 3 for several years. So that was one that we tried to learn from in PHP, and it was that, you know, you maintain the syntax, even if it doesn't make a lot of technical sense to have more than one way to do things. Sometimes, and I'm going to get pelted by tomatoes for saying this at a Python conference, sometimes you need more than one way to do things. If you're trying, because if you're trying to transition people from the old way to the new way, then you have two ways, and you're going to have two ways for a while to help them get across that hump. You might eventually be able to get rid of the old one, and then you can go back to one way and everybody breathes a Pythonic sigh of relief, and we all feel better. But you do have to have the two for a while. The interesting part actually is that PHP, I'm going to learn a slightly different lesson. I'm going to sidebar for a second and rag on the language I'm theoretically representing. PHP has only one string type. It's actually just a binary string. PHP does not have a concept of a Unicode string as a type built into the language. In practice, everybody just represents them as UTF-8 and life moves on. And it turns out nobody really cares. But that wasn't always going to be the case. When Python 3 was first taking its steps into the world, the PHP project was simultaneously developing version 6, even though obviously there is no 6. And what version 6 was going to be was something like Python, where there was going to be a Unicode string type and a binary string type, and it was going to be great. So to ease adoption, like Python 2.6, PHP 5.3 included support for this type of literal, which was going to basically be the binary string type in PHP 6. Except in the end, PHP 6 never happened. The underlying implementation sucked. It used UTF-16, which is just the worst possible choice of an underlying encoding. But more damningly, it really turned out nobody cared. Everybody just used UTF-8. Nobody really cared very much about the fact that you might slice a string in the middle of a code point because there were libraries to do that. And it actually kind of turns out that in the 21st century, people care a lot less about byte level and character level access to strings for most cases than they used to. So it really ended up not being a big deal. So, you know, this syntax never actually happened. But if you run the current stable version of PHP with a B string, it still works. And the reason it still works is because, as I said, we dropped 6, and then when we started work on PHP 7, that was right around the time actually Python re-added support for the Unicode string literal. And that was, we basically looked at that, and we were actually going to drop the binary string support from PHP 7. And then we looked at that and we just went, why would we shoot ourselves in the foot like that? Someone out there has written code that uses this syntax. You can guarantee for basically any, if you write any code for a language, a library, anything, you can pretty much guarantee that it's being used by someone. Even if you don't know it, you may not. So we learned that was an annoying sliver and we didn't do that. We still have two ways to do things, which is less of an issue for us, you know, metaphysically, but nevertheless, we kept it. Another example of something that was, I think, just kind of, that we learned from that was maybe an unnecessary own goal, maybe is a good way of putting it, were some of the changes around iteration in Python 3. In Python 3, lots of things that used to return real materialized lists and arrays and all that good stuff were changed to return iterators or views, which was great because they behave the exact same way and you didn't have the memory usage of like allocating this big thing up front. This was extra good for me. In the same Python job around the same time, I was a new developer at a research centre at a university in Western Australia. And we managed a supercomputer, which was really cool. But we also obviously deployed stuff to smaller servers, and I wrote some code that used range with a really large maximum value on a shared server, and took down like research for a day at this centre. So don't do that, is possibly where I'm going with that. So that was great. Like range didn't change a lot. There was X range, and that turned into range. But like, you know, you could write code that was okay in both versions. But how you actually iterated over how you opted into the new iteration behavior on Python 2 involved a bunch of like method names like, you know, iter this, iter that. And that was great from the point of view of readability. And then in Python 3, you just took off the iter and you got iterators, but again, the function names got removed rather than just aliased, which meant that, again, you needed a tool like 2 to 3 or like 6, as it turned out in the end, to actually get over that hump of how you iterated over things in a cross-version basis. So the lesson here was kind of related to the previous one, which was, this is a few function prototypes from the PHP standard library. You will note that there is a distressing lack of consistency. It's actually worse than this. Some of these have default values that have different behavior depending on what function it is. In the PHP 7, when we were developing PHP 7, there were a lot of emails posted to the internals mailing list along the lines of, hey, we can now break all the things. Let's clean up the standard library. Which makes a lot of sense, because that sucks. I can't remember the order of them, and I've actually like implemented some of these. So for PHP 7, we kept these. Yes, it's terrible. You know, the naming's inconsistent, the ordering's inconsistent, the typing's inconsistent. But it meant that users could bring their code forward. What's probably going to happen in the next major version of PHP is that we'll probably add a new API alongside that has like consistency and reasonable names and standard orders and like type checking. But when we do that, we're going to keep these. Like these aren't going to go anywhere. It's just that when you're actually at the point where you're dropping support for PHP 7, then yeah, you can get rid of these and use the new hotness. But until then, you will be able to use the old version and still be good. I mean, effectively it means you can take PHP code from 1998 and it will probably still work on PHP 7, or very, very close to it. Another thing we looked at from Python 3 but ended up not using was this, from future imports. So future imports were an interesting approach. They were kind of the spiritual version equivalent of like some of Perl's like use version stuff or JavaScript in recent years. And conceptually, they're really simple. You know, you opt in early for the new functionality. The problem though is that, as it turns out, a lot of developers aren't really developers. Particularly in the context of PHP or Python or heavily used open source languages. And what I mean by that is, a lot of your users aren't necessarily going to be like you. Like if you are at this conference, whether you consider yourself to be a developer or not, you are engaged with the Python community, the wonderful Python community. Which means that, you know about the new stuff that's going to come. You went and saw like the testing talk yesterday, which I heard was great and very sad I didn't go to. You went and saw Chris Neugebauer demonstrate awful things in the language yesterday, which was also a great talk and you should watch on YouTube if you didn't see it. It means you know what's coming. You've got a vague idea what the zeitgeist is for the community. But there are many people who write Python who aren't at these events. They're not reading mailing lists, they're not reading blogs, they're not following anyone on Twitter who is a Python developer. they don't know what's coming down the pipe. So it's easily ignored. Like, if somebody doesn't know that there is a from future import to opt into some new behavior, I mean, they don't even know the new behavior is coming, right? Then it doesn't really matter. Okay, yes, you've helped some people by giving them that tool, but there's still going to be a long tail of people who are just occasional users of your language, your framework, your library, or whatever, who are going to get their cheese moved when they upgrade, or worse, when their shared hosting provider upgrades for them. And they're going to wonder why their site broke. So in PHP, being PHP, we of course were contrary and did the opposite. We screamed at users instead about what was going to change. We screamed loudly, and we didn't let them opt in, but we just told them that stuff was going to change. So for a good example of that was, as Betsy mentioned in the intro, I removed the original MySQL API from PHP and PHP 7. And there were good reasons for this that I will happily back up. It was awful. You couldn't use it securely unless you really got the incantations exactly right. It's kind of what Chris was talking about yesterday in terms of like, you couldn't use the Python file API really correctly for a long time unless you had like hideous like try finally blocks all over the place before context managers. So like the old MySQL API was kind of like that. So what we did was we added a warning in PHP 5.5, and I actually should have put on the slide, I'm sorry, which basically said every time you connected to a MySQL database, it generated a warning that basically said this is going to stop working in 2 years. Fix it. So I think that's generally a more useful approach. Don't get me wrong, from future's great. If you have the opportunity to say, hey, there's new stuff coming, you can use it, do it. But if you're going to take away the old stuff, you need to start telling people as loudly as possible in the venues where they are. And the venues where they are might just be their server monitoring or their logging or like their exception handler, because you might not be able to reach them literally any other way. All right, let's talk about carrots. I don't think it'll come as a huge shock if I suggest that Python 3 adoption was pretty slow. And I'm using the past tense on this. This is from a blog post in 2016, and you will note that, I'm not going to do the numbers in my head, but it's like 95% of users were still on Python 2.7, and this was people hitting PyPI. Yeah, it's okay. That's kind of there are different ways to measure this, right? That doesn't mean that people are actually developing on those versions, but it does mean a lot of people are using those versions. So yes, I know these numbers have improved since 2016, but the point I'm getting at is 2016 was 7 years after Python 3 was released. That's quite a long time. A lot can happen in 7 years. I used to live in Australia 7 years ago. One of the things that was surprising when I went back and looked at the Python 3.0 release notes was how little new stuff there actually was. There was a really cool new integer type that was no longer fixed width and is awesome, and I totally want to steal someday for PHP. The new string semantics were definitely better in the long run. I talked about how it wasn't great from the point of view of migration, but you could see also that in the long term, they were a big improvement. Exception handling was definitely better, and most importantly, I was never ever going to have to remember the order of arguments for the super function ever again. But honestly, most of the interesting stuff was already in Python 2.6 or 2.7. Maybe it was behind a from future, but it was already in there. And also a lot of stuff got backported, particularly to 2.7. And here's the thing, you could use all that shiny new stuff and not go to Python 3.0, like this thing that wasn't packaged in your distro for quite a while, that was new, and I think it was even slower, if I remember correctly, like in the very early versions than 2.6 and 2.7. So it was like, why would people bother? It turns out, actually, a lot of people didn't, based on the table that I had a couple of slides ago. Now, this did get better. Python 3, if I think about the things that make Python 3 vastly better for me today than, say, using Python 2, they all came later. The big carrots came later. 3.1 had ordered dictionaries. 3.2 had argparse, which was the first time I'd had an option parsing API. I could actually remember. Yield from was in 3.3, async IO was in 3.4. Jim's giving a talk on that next. I hear it's great. Python 3.7 had breakpoint, which I learned about yesterday from Nina, which is awesome. So the process continues, but the point was that there wasn't much there on day 0 to encourage users to incur the pain to port forward. The only thing they got out of it was warm fuzzies, and unfortunately, I'm going to contradict Vicky just a little bit, warm fuzzies don't actually pay the bills, generally speaking. So for most developers I know, the pain of porting became worth it around about 3.3-ish. And that still didn't take into account waiting for their dependencies to be ported. So in 3.4, in March 2014, Python 3.4 was released. 2/3 of the top 360 Python packages on PyPI had been ported. Now the ones that weren't ported are biased towards the bottom part. It goes that way, basically. But you can take my word for this, there were some big ones that weren't ported, because one of the ones that wasn't ported was Django at the time, or it was like there's a beta, but it still wasn't considered ported on the Python 3 readiness page. So again, like I said earlier, it meant that if you wanted to move forward to Python 3, you actually probably couldn't, depending on what you were writing. Now, I'm pleased to report this has improved massively. As of, I screenshotted this yesterday. This has actually improved a ton since I first gave this talk in November. It was like 3:30 in November. It's now 3:59. So good work, Python community. I'm about to tell you that. I'm glad you asked. Python 3 eventually did provide the carrots and provided a good enough reason to move forward, but I would argue that Python 3.0 to Python 3.0 didn't. Okay, as an aside, here's the one that isn't in there. I'm not actually doing this to call them out. I think I screenshotted this so nobody involved was actually, their names weren't on the slide. So the one package that's not Python 3 compatible is called OAuth. I actually never heard of it. I had to go look it up. It's an abandoned package. It last had a release a decade ago, which is why it doesn't support Python 3. Python 3 wasn't a thing a decade ago. It does, however, provide a salient point that for marketing reasons, in a flat namespaced package index, you really want a good name. I assume that something is pulling this in as a dependency higher in the top 360, and that's why it's getting pulled in. You should use OAuth 2, I believe, is the actual package. For PHP, we didn't want that 7-year, 10-year migration path. Open source language runtimes tend to have smaller teams than you think they do. This is just as true for PHP as it is for Python. And again, this touches on what Vicky was talking about this morning in her keynote. Trying to maintain PHP 5 for more than a couple of years of overlap was probably going to stretch us further than we could go. Even though we didn't do a lot of language level changes, there were a lot of runtime level changes that meant that porting code and fixes back and forward was very difficult between the two versions. So in spite of years of discussion, PHP 7 didn't happen until we had a really compelling story for why you should upgrade. Now for PHP, it was around performance. PHP 7 was 2 to 3 times faster than PHP 5 for the same code, generally, except WordPress. And this was that was a good story for us. Now, different projects will have different carrots. Maybe it's new functionality, maybe it's being able to use it in new ways, being more composable, but it has to be present. One thing I actually just want to call out on the slide, which is not directly related to my talk. When I first gave this talk in November, those contributor numbers were very similar. Python, I think, was 680 and PHP was 651. So the CPython project has had more than 250 new contributors in the last 9 months. So whatever the Python core community is doing, they're doing a really good job, because that's awesome. For PHP, the blue one is PHP 5, the red one is PHP 7. This is users hitting Packagist, which is our version of PyPI. Again, it's is that really? I don't know how scientific that is, but it's at least equivalent to the numbers I showed you earlier for Python. Basically, I mean, you can see PHP 7 didn't even exist until 2016, and it is now 90% of the users hitting Packagist. So, I think there should be a banner, mission accomplished, basically. We learned 3 key lessons from the Python 2 to 3 transition that allowed us to do this in 3 years instead of in 10 years. And they were to break things cautiously, to maintain terrible things, even if it means you have more than one thing, if it makes your life better. And to make sure you expand that zone of overlap in that Venn diagram so that your downstream users don't hate you. Thank you very much. I will tweet out a link to the slides. You can find them there. You can find me on Twitter at @elgnome, and you are more than welcome to chat to me about any of the stuff I just talked about for the rest of the conference. Thank you.
Thank you very much, Adam. Here's your fancy mug. We don't have time for